All right, in this lesson, we're going to talk about the binomial theorem. Now, the binomial theorem is incredibly helpful, and it just exploits the patterns of expanding binomials out. And so it's very, very helpful for a variety of reasons. The formula looks much messier than it actually is, though. So we'll start with a binomial, a plus b to the n. And if you were to multiply all of that out, you would see that it's going to be a bunch of terms added together. So that's where the series comes into play. The series is going to go from r equals 0 to n, and then we're going to have a coefficient that's read n choose r. N choose r. And I'll explain that more in just a second. We'll have our a raised to the n minus r and our b raised to the r. Now, this n choose r, that's a combination. If you have taken a statistics or probability course, you might have seen that before, but it's got its own formula, n factorial over r factorial times n minus r factorial. You also have a button on your calculator that does this for you, so we don't really have to worry about the formula and number crunching all that much, even though it's not very difficult. So that's the binomial theorem. The example we're going to look at is going to be the binomial 2x minus 3y squared raised to the fourth. Now, I'm going to come through and I'm going to label everything. Our a value would be 2x. Our b value would be a negative 3y squared. Be real careful on that, okay? Don't forget to include the negative. And the n, in this case, would be a 4. So to get this set up, we're going to have the sum from r equals 0 to 4. We'll have 4 choose r, 2x raised to the 4 minus r, negative 3y squared raised to the r. Okay? Now, I found that sometimes doing these vertically is helpful. So I'm going to come over here and I'll start here with r equals 0. So when r equals 0, we get 4 choose 0, 2x to the 4 minus 0, negative 3y squared to the 0. Okay? When r equals 1, we're going to get 4 choose 1, 2x to the 4 minus 1, and negative 3y squared to the first. And again, you're probably picking up pretty quickly on the patterns here. 4 choose 2. Then we'll have r equals 3, and we'll have to stop then at r equals 4. Into the 4. All right, so I've got it all written down. The 4 choose 0, 1, 2, 3, 4, all of these right here, those are all combinations, and those are going to be the initial coefficients that you start with. You likely have a button on your calculator that says something like NCR. It's probably pretty close to where the factorial button was from an earlier section. So you'll find that, and you'll need to be able to compute this in your calculator at least. So what they end up being is 1, 4, 6, 4, and a 1. So when you punch those in your calculator, make sure you're getting those. And then it's just a matter of simplifying it all down. Now we do have to remember though that it is still going to be this guy plus the next one, plus the next one, plus the next one, plus the next one. So let's see here. These clean up. This first one would be a 16x to the fourth. Then we'd have a negative 96 x cubed y squared. Then a 216 x squared y to the fourth. A negative 216 xy to the sixth. And then finally an 81 y to the eighth. And again, we got to add all these things up. So our final answer then would be a 16x to the fourth minus 96x cubed y squared plus 216 x squared y to the fourth minus 216 xy to the sixth plus 81 y to the eighth. So we put it all together, that's what we end up with. And if you were to, which you wouldn't, multiply that out 4 times, that's what you would come up with. So again, we're just exploiting the fact that these binomials, when you expand them, are just a bunch of patterns, and the binomial theorem allows us to do this pretty quickly and efficiently.